Hello friends, this is Bright here. In this video, I am going to illustrate TCP socket programming using multithreading. Here, one thread we are going to use for sending data and another thread we are going to use for receiving the data. Let us see how it can be implemented in Python. So I am using editor Python. So here I have two files. One is system1.py and other one system2.py. So if you have two different laptops, you can put system1.py in one laptop and system2.py in another laptop. I am going to show both in same machine. Since we are going to use multi-threading, we have to import the thread class. So I am going to use from threading import thread class, and also we have to import socket module. Now I am going to create a class, name it as send thread, or we can say sending thread, which is a subclass of thread. So its purpose is just send data and override its constructor. Call its superclass constructor. Override the run method, and let me just put it. Later we'll code it. So this is an overview for sending thread class. Similar to that, I am going to create another subclass of thread, that is to receive the data. Let us say receiving thread, subclass of thread. Here also first override the constructor, call the superclass constructor, and override the run method, and let me just put pass. Later we'll code here. So the layout for both classes are ready. Now the first step is create a socket object. For that, let me name the socket object name as s equal to socket dot, that is module dot class name. Object will be created, and if it is of TCP, it is not mandatory to pass any argument to the constructor of socket, because I will show here what is the body of the actual predefined class socket. You can see that here the constructor init is kept with default arguments. If you don't mention any values, you can see that if family is equal to -1, it takes a value AF init, that is internet address family. If it is of AF init, it uses IP version 4, and for the second argument, it takes the default value sock underscore string. This is for TCP. So here I am going to mention these things explicitly. So how it can be done? So to mention the first argument, use the module name socket dot AF init. The second argument, socket dot sock stream. If you are coding for UDP protocol, we have to use sock underscore dgram. So these are the two arguments. So let me explain it further with detailed comments. The first one, internet address family. That is a full form of AF, address family, INET, internet. So it uses a value IP version 4. If we want to use IP version 6, we have to take like this, AF underscore inet 6. If you don't mention anything there, it takes IP version 4 as internet address family. And the second one represents we are using TCP. Socket object is ready. Second step is bind socket with a port number. For that, s.bind pass a tuple object and the first argument, the system1 IP address. So I'm mentioning the local host IP address. And the second argument, to which port number I would like to bind my socket object. Then the next step is keep system1 in listening mode so that it can accept the incoming connection request. For that, s.listen. After that, accept the incoming connection request. For that, s.accept. It returns a pair of values, let us say v1 and v2, where v1 is a new socket object through which we will be sending data as well as receiving data. v2 contains the address of the system which sent the connection request. So let us give some meaningful name. I am replacing v1 with my socket. So the first value represents the name of the newly created socket object when the incoming connection request is accepted. And the second one is, I am just putting it as address. So this address contains the details of the system 2 which send the request. Now we are going to create a thread to send data. For that, we created a class called sending thread. So let us say send thread object name equal to sending thread. Similarly, create another thread to receive data. For that, we have a separate class receiving thread. You can see that receiving thread objects are created, or we can say both threads are created. Now start both threads. For that, send thread dot start, receive thread dot start. Now when we call send thread dot start, the sending threads run method will be invoked, and here we have to write code to send data continuously. So we need a loop. We can put an infinite while loop which will be keep on sending the data. But for sending data, we need mySocket object. We can see that here we have the mySocket object. So this mySocket object, we have it to bring into the run method. For that, pass this mySocket object as an argument through the constructor of sending thread, and we have to receive it in the constructor. I am just giving the same name, or we can give different name as you like. Say that self dot mySocket equal mySocket, and now we have the mySocket object. We can say self dot mySocket dot send. Now in send method we can pass only bytes, so convert the data into bytes. Let us say the data is welcome, and don't forget to put the encoding type which we are using. You can try with ASCII also, but this time we are going to get this data from the user during runtime. So instead of directly typing welcome, we can use input function. So writing like this, data variable equal to input. So that data we can directly pass here. So this is the code to send data continuously. Similarly, we have to put code in receiving thread. For receiving thread also we need the same mySocket object. So what we have to do is take this mySocket object, pass it as an argument through the constructor of receiving thread, receive it by a variable in the constructor, and attach it with instance. And here write the code to receive data continuously. UOUS, yeah. So write an infinite while loop, and let us say message equal to self dot mySocket dot receive. We can specify the input buffer size. We can print it after decoding that message by using encoding format UTF-8. So here message will be decoded, then it will be printed. So this is for receiving thread. So two threads are ready to run. Yeah. Similarly, we have to code for system 2. Start with from threading module, import thread, import socket. Here also create a separate class which is a subclass of thread to send data. So here let us say my sending thread. Thread subclass, override the init, it is override the constructor, call the superclass constructor, override the run method. So here we have to write code to send data to system 1. So we can write a while loop and we have to write the necessary code. Let me put only pass now. So create another class. Let us say that my receiving thread, which is a subclass of thread. Override the constructor, call its superclass constructor, and override the run method. Here write the necessary code to receive data from system 1. So we can put an infinite while loop. So I'm just putting pass for time being. Now create a socket object is equal to module dot socket dot address family init socket dot sock stream for TCP. Now binding is optional here. We are going to send a connection request. For that, s dot connect, we have to pass a tuple object and the first argument is IP address of system 1. Since in my system I am running in my system I am going to run system 1 and system 2 in my here I am going to run system 1 and system 2 in the same system. So I can put the local system address or the local host address 127.0.0.1 followed by the system 1 has a socket, that is S is the name of the socket object. It is bound with a port number 2000. So through the port number 2000 it is listening for incoming connection request. So we have to mention that same port number. So this two arguments we should be very careful. Here what is the IP address of system 1? and through which port number system 1 is listening. So when this connect method is executed, here the accept method will be invoked. Then we are starting the sending thread and receiving thread. Now we have to create a thread to send data to system 1, and we have to create another thread to receive data from system 1. For sending thread, we have a class mySendingThread. So create an object for that. Let us say that my send thread, some name for the object. And similarly, create an object for my receiving thread subclass. Let us say my receive thread. Thread objects are created. Now we can start both threads. For that, my send thread dot start, my receive thread dot start. Now my send thread dot start automatically triggers the run method, and here we have to write the code to send data. For sending data we need the socket object, but here the socket object is not available. The socket object is available here, so take the socket object name, pass it as an argument through the constructor of mySendingThread, and through the constructor we can receive it. Let us say that my socket. We can attach it to an attribute mySocket, that is self.mySocket equal to mySocket. And now we can write self.mySocket dot, this is for sending the data. So send convert the data to bytes and send it. So for that we are using a variable data equal, call the input function and pass data as an argument to bytes method with necessary encoding name. So here everywhere we are using UTF-8, so no confusion will be there. So here read the data from user during runtime and convert it into bytes by using UTF-8 encoding, then send it to system 1. Similarly, for receiving thread, we have to write self.mySocket.receive, but here the mySocket object is not available here. We have the socket object, yes, and take this yes, pass it as an argument through the constructor of myReceivingThread, and we can receive it here. We can use any variable name. I am going with mySocket, attach with some attribute self dot, let us say mySocket equal to mySocket. So now we have that socket object. Through this attribute my socket. We can say self dot my socket dot receive the data, and we can keep some input buffer size, let us say 1024, and that can be stored in some variable message. We can decode the message by using the format, encoding format UTF-8. So from there, when we are sending, we are using UTF-8 for encoding. Here we are decoding using this format, same format. Then print it. So this is about system 2. System 2, we have my sending thread, run method, a while loop for keep on sending the data. Similarly, in receiving thread, we have a while loop in run method which will be keep on receiving the data. So we have the socket object, send a connection request, then start both threads. Here we have to run system 1 first, because system 1 is only in listening mode and accepting the input connection request. So first let us run system 1. Run system 1. So it is giving a bind error. It shows that address already in use. We can go with a different port number. Let us say 2010. Now we should be careful. In system 2, in the connect method, we have to use same port number, because now system 1 is going to listen through the port number 2010. Now let me run again system 1. Yes, it is running successfully now. Now let me run system 2. That is also running smoothly. Now from anywhere we can send the data. Let me start from system 1. Let us say that, hi, I am from system 1. We can see we are getting the data. We can continuously send the data from system 1. Are you available there? Yes. And here from system 2 also we can continuously send hello. Yes, it is there. I am not free now. Yes. So here we have two threads. One thread will be keep on sending the data, and another thread will be keep on receiving the data. That's all. Thank you for watching this.